Do you remember that Keto-CTA study? It was the one looking at lean mass hyperresponders and plaque progression. You might remember it as Plaque Begets Plaque, ApoB Does Not, longitudinal data from the Keto-CTA trial. It's not a randomized controlled trial. The title is now Longitudinal Data from the Keto-CTA Study, Plaque Predicts Plaque, ApoB Does Not. The title was changed and much of the beget and causal language was toned down, probably for good reason. Well, using their raw data, I rebuilt the study's figures and models and examined the statistical methods and reporting. And what I found shocked me. Here's what we'll cover. Charts that show the data incorrectly, manually edited, conclusions made without reporting the analyses, and some just wrong, statistical modeling choices that obscure and attenuate relationships, and why the statistics can't support the headline claims. To summarize the study, it was a one-year study following 100 lean adults on a ketogenic diet with elevated LDL cholesterol due to the ketogenic diet. They had coronary CT scans at the start or baseline, and 1 year later at follow-up. And that was to measure the changes in arterial plaque, especially non-calcified plaque. The main outcome of the study was the change in non-calcified plaque volume from baseline to follow-up. However, the study's main conclusion was that LDL cholesterol and ApoB were not associated with plaque progression in lean, metabolically healthy people on a ketogenic diet. And both of these markers are generally linked to plaque, with ApoB being the more reliable marker. So you can see why this study was controversial. And when I first read the study, I did have some questions regarding the statistical analysis, but without the raw data, it's hard to verify anything. Well, because the organization funding the study actually released some of the raw data. So from that data, we can verify many things in the study. I found some major problems and some I definitely was not expecting. But I want to be clear about something. This analysis will focus only on the data as presented in the study and the validity of its conclusions. I'm not concerned with diet debates. I'm not concerned with whether statins are good or bad or anything. I'm not criticizing the keto diet. I'm not anti-keto. I am anti-bad statistical methods and bad statistical analyses. I want to answer the question, do the data and statistical methods support the study's conclusions? The study's main charts appear to contain manually modified axes. The main chart showing plaque volume, or percent atheroma volume, has a scale that goes from 0 to 10%. However, the actual data go up to 20%. This makes the amount of plaque progression and the absolute amount of plaque appear to be half as what it actually is. Let me be clear about this. In this chart, all of the data is displayed. There's nothing truncated or hidden. However, when I recreated the chart using the raw data, you can see that it goes up to 20%. And similar to that, in figures 2E to 2F in the study, the y-axis is change in total plaque score. That y-axis should go from -1 to 6. But we're not done. There's still another problem in the main figure. In both charts, the red shaded area is supposed to represent the interquartile range, or the middle 50% of the data. Now, in this study, in one chart, it shows the red shaded area below 0, which is physically impossible. Here is what it should look like in the chart that I recreated. And in figure 1A, you can see that the red shaded area is basically on the 0 line. That is not what it should be. It should be the 25th percentile, which is what I'm showing here in the chart that I recreated from the raw data. But in general, if you look closely at the y-axis tick marks and labels in any chart, the numbers don't align with the tick marks, and they must have been altered manually and sloppily. I don't know why they would have made such an elementary mistake. Why not just show the chart as generated by the software? When I reproduced this chart, the numbers do automatically line up with the grid lines. And just to be specific, the study states that the software R was used, and the package used to visualize the data was clearly ggplot. I've made thousands of charts with ggplot over the years, and these misaligned axes labels just do not come from that software. They're clearly from manual edits in a separate program after exporting the charts. I don't know why. This is a very strange, and I assume just a stupid mistake. But the sloppiness isn't limited to the figures. When you look at the reported results themselves, there are major holes. The study makes multiple claims about the lack of association between cholesterol and plaque. The abstract states neither change in ApoB, baseline ApoB, nor total LDL-C exposure were associated with the change in non-calcified plaque volume, NCPV, or TPS, that's total plaque score. And neither total exposure nor changes in baseline levels of ApoB and LDL-C were associated with changes in plaque. Changes in baseline levels. However, many of the statistical models required to support these claims are missing from the paper. They're just not reported. They state conclusions for analyses they never show. Where is the change in NCPV to baseline LDL-C model? It's not reported. Where are any of the models with total plaque score as the outcome? Not reported. A chart of TPS versus ApoB model is even shown in the central illustration here, but the model output, it's not reported, so we can't verify anything here. Oh, speaking of the TPS models, the study claims that CAC, or coronary artery calcium, is associated with changes in TPS without showing the model output. But I fit the exact same model with the exact same data and found that CAC is actually not associated with changes in TPS, directly contradicting the study's claim. Additionally, for all the linear models they actually do report, they report no confidence intervals for the model coefficients. This is a serious reporting omission, and the journal should have caught this, and it is inconsistent with standard statistical reporting practices. Okay, but even when the models are reported, the study's chosen statistical methods make a real signal very difficult to detect. So how you statistically model data can dramatically affect the results and interpretations, and this study makes some peculiar choices. Two main choices drive the problem. So first, all the core models used change scores as the outcome. That means just the difference between follow-up and baseline. Now, it sounds simple and intuitive. Don't we just want to know how much plaque changed in 1 year? Yes, but actually this way of measuring change distorts the picture. So in general, change scores add noise, suffer from regression to the mean, amplify measurement error, create artificial correlations with baseline values, and are less likely to detect real effects. In other words, they just ignore the baseline values or where you started. Generally, statisticians discourage using change scores, except in rare, carefully justified situations, and this is not one of them. Second, all the core models examined one factor at a time, what statisticians call univariable models. Univariable models ignore confounders. That means they ran one model with baseline plaque as the predictor and a separate model with ApoB as the only predictor, both aiming at the same outcome, change in plaque. But they also didn't adjust for basic factors like age and sex, even though those are known determinants of plaque progression and were available in the dataset. In other words, their conclusion isn't ApoB has no effect, it's ApoB looked like it had no effect when other important factors were ignored. That's classic omitted variable bias. And the study focusing on Plaque Predicts Plaque is just a bit strange. So they measure the same person's plaque 1 year later. Of course it predicts it. It's just within-person persistence of plaque, like rust on a car predicting rust a year later. They frame it as a contrast with ApoB not predicting it, pitting a somewhat persistent state predicting itself against a risk factor. These are two different things. Now, the fix for change scores and univariable models is pretty straightforward. The model in this study, change in NCPV versus ApoB, asks the question, does ApoB predict a larger absolute change in plaque, regardless of starting plaque and ignoring age and sex, which are known determinants of plaque progression? That doesn't sound very clinically relevant. I think the better model would be follow-up NCPV versus baseline NCPV and ApoB and other factors like age and sex. And this model asks the question, at the same baseline plaque, age, and sex, is higher ApoB associated with more plaque at follow-up? That seems like a more clinically relevant question. And before anybody says, it's just an exploratory analysis, we don't need the full model, right? Well, you should note that the term exploratory shows up only once in the study, in the final paragraph of the whole study. It's not in the abstract, it's not in the statistical analysis or the discussion, and actually the original version never even mentioned that it was an exploratory analysis. But the rest of the study is written as if the analysis were a definitive test and confirmation of its hypothesis. And we should remember that exploratory results are for generating questions for further research and not definitive tests. But even if you're still not convinced and you accept the study's statistical methods, the conclusions do not stand because the models they used violate important statistical assumptions that they rely on. The study explicitly states that all linear model assumptions were corroborated. However, it does not show any diagnostic plots or tests or evidence to support this claim. So linear models are only reliable when their assumptions hold, and if they don't, the effect estimates and the p-values can be misleading or wrong, and so would the claims of statistical significance or non-significance. So my analysis of the raw data shows assumption violations in each of the 4 plaque models. And each model shows at least 2 violations. But this isn't exactly how the study claims to have corroborated the assumptions. It used the R function performance check model. Well, let's look at that output, what they were looking at to corroborate the models. So these charts show what we call diagnostic plots, a visualization of the model residuals or errors, which we use to help determine if the model appears valid, if the statistical assumptions are met. This is the exact same function on the exact same data. You can look at the statement above each individual chart to see what the green reference line should look like. And you can clearly see many issues with these plots. So for the change in NCPV versus NCPV at baseline, you can look at the homogeneity of variance chart, and you can see that it increases as the fitted values increase. This appears like a violation. But one of the ones that's totally clear, no argument, is the change in NCPV versus total plaque score at baseline. Look at the residuals here and how humongous they are. I mean, no statistician could look at that and say, okay, there's no problem with this model. The errors are crazy. I would say these are definitely not corroborated. There are big problems with using a simple linear model on this data. Unfortunately, I cannot test all of the models because we don't have the ApoB or cholesterol data. We only have the plaque data. However, there is a strong likelihood that the ApoB and LDLC models also violate these assumptions because it does appear that at least most of the issues are outcome driven, meaning the change in NCPV. Sorry for all the statistical details here. All of these issues with the models just means that the reported p-values are unreliable, so any claims of statistical significance or non-significance are also unreliable, and therefore the study's conclusions are not supported statistically as shown. In other words, these results would not pass a statistical review. So those are the 4 major problems that I found while going through the data and the study in more detail. But there's actually more, and if you want a full deep dive, we did 2 long podcasts that go through these problems and many more in detail. But I would also like to note that despite all the problems with the study, I think this data set is very valuable and does warrant a proper analysis. And I give credit to the funding organization for releasing the plaque metrics. That level of transparency is still uncommon in health research and really should be acknowledged. I hope that they'll release the full data set at a future point, but that transparency should not stop at the data set. You should release the code, release any pre-specified statistical modeling plan with the full outputs, the confidence intervals for the models, and the diagnostic plots. Basically just release the data set and release the code used to analyze the data so that the results are reproducible. Why would they not do this? Okay, the statistical verdict. So remember the question I wanted to answer in the beginning. Do the data and statistical methods support the study's claims? Well, I think you can tell my answer is no. No, they don't. And I'd say overall, the study is sloppy. It contains significant basic graphical and reporting errors. It reads like a rushed, rough draft thrown together at the last minute with no pre-specified statistical modeling plan or even a basic editorial review. It uses strong, overstated confirmatory language based on a weak exploratory analysis. From a statistical standpoint, this study cannot support the claim that ApoB is not related to plaque progression. Again, I'm not trying to bash keto here, and no study is perfect, but this study definitely needs serious revisions. The methods and reporting don't support the headline claims, and I would not base any health decisions on this paper. And of course, there's a link in the description for my GitHub repo if you want to look at my code.